Hello, in this lesson we are looking at inverse functions. Our essential question is, what is an inverse function and how do you know it's an inverse function? What are inverse functions? Functions that undo each other are called inverse functions. Here's an example of an inverse function. The original function f of x is equal to 2x plus 3, and its inverse is g of x equals x minus 3 divided by 2. Inverse functions interchange the input and output values of the original function. The domain and range are also interchanged from the original function to the inverse function. For example, in the original function you can see that at x equals negative 2, our y value is negative 1. In the inverse function, at x equals negative 1, our y value is negative 2. Similarly, in the original, at x equals negative 1, y equals 1, and here at x equals 1, y equals negative 1. So basically, the x and y values have switched positions from the original to the inverse function. Here is the graph of the original function, f of x equals 2x plus 3. Here's the graph of the inverse function, g of x equals x minus 3 divided by 2. Notice that the inverse is a reflection of the original function across the line y equals x. The inverse of a function f is denoted by f to the power of negative 1. You read f to the power of negative 1 as the inverse of f or as f inverse. The notation f of x is used for functions, but not all f inverses may be a function. Here's our first example. What is the inverse of f of s? What are the graphs of f of s and its inverse? Since we are given the table and not an equation, to find the inverse of f of s, all we need to do is switch the x and y values. In our original function, we have x equals 0 and y equals negative 1. In our inverse function, we have negative 1 for x and 0 for y. Same thing here. At x equals 2, y is 0. In our inverse function at x equals 0, y is 2. We can continue filling the table. At x equals 2, y equals 3, and x equals 3, y equals 4. Let us now graph f of s. Here are the points for the graph of f of s. Now let us graph the inverse function of s. Here are the points for the function f inverse of s. Notice that the inverse of the function f of s is a reflection across the line y equals x, in that their distance from the line of symmetry y equals x is the same. Finding an equation for the inverse. To find the inverse of a function, switch the roles of x and y, then solve for y. Let's take a look at an example. In this function y equals x squared minus 1, we are asked to find the inverse. To do that, first switch the roles of x and y. So I'm going to rewrite this as x equals y squared minus 1. From here, I am now going to solve for y. Start by adding 1 on both sides. So I get x plus 1 equals y squared. Isolate y by getting rid of the square, and to do that, we need to take the square root of both sides. And so when I take the square root of both sides, I get y equals plus or minus the square root of x plus 1. So the inverse of y equals x squared minus 1 is y equals plus or minus the square root of x plus 1. Graphing a relation or function and its inverse. What are the graphs of y equals x squared minus 1 and its inverse y equals plus or minus the square root of x plus 1? There are two ways that we could graph this. We could either graph the parent function and then do the transformation. In this case, the graph would go down by 1. Or we can do a input-output table, and that's what I'm going to do over here. So I chose the values for x as negative 2, negative 1, 0, 1, and 2. I'm going to use these values and replace the x in our function and evaluate that function. So at x equals negative 2, I have negative 2 squared, which is 4. 4 minus 1 is 3. Negative 1 squared is 1. 1 minus 1 is 0. 0 squared is 0. 0 minus 1 is negative 1. 1 squared is 1. 1 minus 1 is 0. 2 squared is 4. 4 minus 1 is 3. I'm now going to plot these points on my coordinate plane. Now I'm going to connect the points of my graph to create a parabola that shows the function y equals x squared minus 1. And here is the graph of y equals x squared minus 1. Now let us graph its inverse, y equals plus or minus the square root of x plus 1. Again, we can graph the parent function for the inverse, which is the square root of x, or we can do an input-output table, which is what I am going to do. For this function, I chose the values for x as negative 1, 0, 3, 8, and 15. I'm going to plug it into the equation y equals plus or minus the square root of x plus 1 and simplify it. At x equals negative 1 plus 1 is 0, and the square root of 0 is plus or minus 0. At x equals 0, we have 0 plus 1, which is 1. The square root of 1 is plus or minus 1. At x equals 3, 3 plus 1 is 4. The square root of 4 is plus or minus 2. At x equals 8, 8 plus 1 is 9. The square root of 9 is plus or minus 3. At x equals 15, 15 plus 1 is 16. The square root of 16 is plus or minus 4. In this graph, I don't have the x value for 15, so I'm just going to plot the x values for negative 1, 0, 3, and 8. Connect the points of our graph to get the inverse of the function x squared minus 1, which is y equals plus or minus the square root of x plus 1. Notice that the inverse of the function x squared minus 1 is not really a function because it doesn't pass the vertical line test. And so the inverse of x squared minus 1 is not a function. In our next example, we are to consider the function f of x is equal to the square root of x minus 2. First, it is asking for the domain and range of f of x. Here's a graph of the function f of x equals x squared minus 2. Notice that our domain actually starts at x equals 2. So our domain is all values of x such that x is greater than or equal to 2 because it starts at 2 and less than positive infinity because it goes all the way to infinity. Our range is y is such that y is greater than or equal to 0 and less than positive infinity. This is when we plug in 2 into our equation and we get that y is equal to 0 and goes all the way to infinity. Now we are asked to find the inverse of the function f of x equals x minus 2. So we start by replacing f of x with y is equal to the square root of x minus 2. Then we switch the positions of x and y so that we get x equals square root of y minus 2. And now solve for y. First, get rid of the square root by taking the square of both sides. So we get that x squared is equal to y minus 2. Isolate y by adding 2 to both sides to get y is equal to x squared plus 2. So the inverse of the function f of x equals square root of x minus 2 is x squared plus 2. What is the domain and range of the inverse of f of x? Remember, the inverse of f of x equals the square root of x minus 2 is x squared plus 2. This is what its graph looks like. The domain is all real numbers. In set notation, we can write this as x is greater than negative infinity and less than positive infinity. Our range for the inverse function starts at y equals 2 and goes all the way up to infinity. So in set notation, y is such that y is greater than or equal to 2 and less than positive infinity. Is the inverse of the function f of x equals square root of x minus 2 a function? Explain. The inverse of the function, the square root of x minus 2, is a function because it passes the vertical line test. Notice that in the vertical line test, each one of the points on the inverse of the function passes the vertical line only once. And so the inverse of the function f of x equals square root of x minus 2 is a function. All right, that's it from me. I'll see you all soon.